Hello students. Today our topic is clippers. So in last class we have already discussed about types of clippers. In that series clipper, parallel clipper, shunt clipper, those two are completed. In series clipper also we have two types: positive series clipper, negative series clipper. And again in positive series clipper, two types: series with positive reference and a positive series with a negative reference. Okay. So now the topic is a positive series clipper with a positive reference. The circuit diagram. We know already positive series clipper without this part. Okay, in previous session we discussed about positive series clipper without reference, without giving an external voltage, without giving battery connection to this circuit. Okay, now we are giving external voltage, extra voltage to this circuit. Then what happened here? Series clipper means a diode is connected in series with the load. Then the type of clipper is called as series clipper. So what is mean by clipper? Clipper means cutting some portion of input signal, either positive side or negative side. Positive clipper means the positive part will clipped off. Negative clipper means negative part will be clip off, right? Here we are giving the bidirectional signal, that is a AC signal as input voltage. Positive side, that is considered as plus Vm, negative side as minus Vm. So this now this is the signal, entire signal is giving to this diode. We have to take two conditions. So here first condition is V in greater than to Vr, and the second condition is V in less than to Vr. So you have to remember these two conditions in all types of clippers. So here we have to know the two conditions. First condition is V in greater than to Vr, which means input voltage is above the reference voltage, which means input is at a positive peak. If input is at positive peak, this is positive peak is giving to negative terminal of the battery, then this diode is going to be reverse bias condition. When it is in reverse bias condition, it acts like a open switch. Open switch. So the input voltage does not allow from input side to output side. Okay. So in generally we have the output voltage as 0, but here we are giving some external voltage. Let it be that voltage is as 2 volts, 3 volts, let it be. Okay. So in that condition V naught is equals to VR. Next condition, V in less than to VR. V in less than to VR means input voltage below the reference voltage. Below the reference voltage. So here below the reference voltage means negative peak. Negative peak. So negative peak is giving to negative terminal of the diode. So negative is giving to same terminal of the diode. So obviously this diode is going to be forward bias condition. When it is in forward bias condition, it will be acts like a on, okay, acts like a closed switch. Closed switch means when diode is in a closed switch condition, obviously this input signal, whatever input is there, that input is moving from input side to output side. So in this condition, V in less than to Vr means input is negative half. During negative half, diode is in on condition. Forward bias condition, it acts like a closed switch. So obviously output is equals to the input voltage. So V naught is equals to V in. Okay. So these are the two conditions. So based on these two conditions, we have to take the waveforms, right? So this is the input waveform. What is the first condition? V in greater than to VR. V example, this total voltage like plus 5 volts, minus 5 volts. So here reference voltage, example reference voltage, here I am taking the reference voltage, positive reference, right? So positive reference is a 2 volts. This is 5 volts minus 5 volts. Okay, right. So first condition, V in greater than to VR. V in greater than to VR means reference above the reference voltage, which means input signal is at a positive position. Input signal is at a positive side. Then what happened here? When input is a positive, obviously V naught is equals to reference voltage. Reference voltage. So here the reference voltage is 2 volts. Okay. So output is as same as the reference voltage. Next, V in less than to VR. V in less than to VR means input voltage less than to reference voltage, which means the input is at a negative side. Negative side. If input is at negative side, then obviously output is as same as the input voltage. So here output is as same as the input voltage, like this. Okay, go for next. V in greater than to VR, diode V naught is equals to VR. Okay, input and output waveforms of a positive series clipper with a positive reference. Okay, observe which part will cut off here, clipped off here, positive side only, positive side only. So this type of a clipper is called as a positive series clipper with a positive reference.